fact, I kind of have a unit circle tutorial, not a tutorial, but I've done it so many times that it feels like I do it the same every time.
And apparently there's like 100 and something of them.
Yeah, there are, but you don't need to memorize it like that. There's three key angles: 30, 45, and 60. And that's 90, that's 180, 270, 360. Over here, whatever angle, if we're in the second quadrant, let's number these quadrants. 1, 2, 3, 4. And also, let's put what, are you familiar with the term, the reflex angle, or reference angle, excuse me?
I've heard of it, but I don't remember it too well anymore.
All right. Let me write the rest of this thing. What they expect you to know is all 6 trig functions for all multiples of these 3 basic angles. For example, they want you to memorize, you do have to memorize the first quadrant results, but there's an easy way to do that, and that's with these 2 triangles that I'll put down here on the left. These are the 2 triangles you've been studying for 3 years probably. They're a 30-60 and a 45-45, both right triangles.
Okay.
And I'm dimensioning them. Everything I'm putting on this page, I want you to memorize.
All right.
And it'll let you answer all of the trig functions for all 96 combinations. For example, if you look down here at the left, what's the sine of 30?
The sine of 30.
Do I need
So opposite over hypotenuse.
Okay, let me put SOHCAHTOA there. That's something else you want to memorize. So what is the sine of 30 degrees?
1 over 2.
Okay, what's the cosine of 30 degrees?
Square root of 3 over 2.
And what's the tangent of 30 degrees?
1 over square root of 3.
Okay, which rationalizes to what?
So it's multiplied, so it's square root of 3 over 3.
Right. Okay. That's funny, I hear that noise and I keep thinking my dog's walked into my office because I hear a little squeaky. No,
Yeah, that's my door.
it's on your end. That's
My mom wants to talk to you real quick, actually.
okay.
Hi, how are you?
Good. Good evening to you.
Good evening. I owe you money. I haven't received a bill.
Oh, I sent an invoice a couple weeks ago, but I'll send another one after tonight.
Oh my gosh.
Pardon?
Oh my God. I don't remember. Oh boy.
No problem. No problem at all.
Yeah. No, I kept asking. I asked Taylor last time he met with you about a bill. I'm glad I got on. Yeah, if you send me something tonight, I'll get it out to you tonight. I'll put it right on, okay?
Okay.
Yeah, my apologies. Oh gosh.
No problem.
Yeah. All right.
No
Thank you, sir. Thank you so much.
You're
Okay, here's Taylor.
All right.
Oh boy. Okay.
I'm back.
Thank you.
She's fine. She doesn't need to worry about any of it.
Okay, thank you.
Okay. In other words, I can figure out what is the tangent of 45 degrees.
The tangent of 45, that is 1 over square root of 2. So then that would be square root of 2 over 2.
Okay, tangent's actually opposite over adjacent, so it's
so that's 1 over 1, yeah.
okay. So you can get all of your first quadrant angles, anything less than 90, from these 2 triangles. Okay?
Okay.
Now let's talk about, let's hold off on the quadrangles for a minute. because I don't have enough room on here to put everything on here. Let's talk about angles that are in the second quadrant. For example, 150 degrees. The way you do second, third, and fourth quadrant is you use this expression here to convert it to a first quadrant, the equivalent first quadrant angle. In other words,
Okay.
if I said, what is the sine of 150 degrees? You plug in 150 for theta, and that gives you 30 degrees. So whatever the sine for 30 degrees was, that's what the sine for 150 degrees is, with one exception, and that is its plus or minus sign. All students take
calculus.
Calculus. That tells you what the plus or minus sign should be in every quadrant. Let's keep talking about sine for a minute. So, in other words, the sine of 150 degrees is the same as the sine of 30 degrees, which is 1/2. And it's positive because that's what the S in the second quadrant means, is that only sine is positive in that quadrant. First quadrant, all trig functions are positive. Third quadrant, only tangent. Fourth quadrant, only cosine, along with their reciprocals. In other words, it's not just the sine, it's also the cosecant. So you have to remember that, because the cosecant is just the reciprocal of sine, so if the sine is positive, cosecant has to be positive also. Same with cotangent and same with secant in these quadrants. Let's not even write those because I don't want too much information on here. Pretty much everything I have on there is going to allow you to answer any question. Let me test you. What's the sine of 210? Very first thing you have to figure out is which quadrant is it in?
Quadrant 3.
Okay, now use that formula, theta minus 180.
So that would be 30.
So what's the answer? What is the sine of 210?
So that's opposite over hypotenuse. So that's -1/2.
Good. What's the sine of 315 degrees?
So that would be in quadrant 4. So then 360 minus 315, that will be 45, I believe.
Correct. Now what's the sine of 45?
So opposite over hypotenuse, so that's 1/√2. And since it's it'll be a negative.
Correct. Very good. Now I think you can kind of see what's happening here.
The pattern.
Well, instead of having to memorize 96 things or 64 things, whatever, you're going to memorize stuff in groups of 3 and 4. In other words, when you memorize this triangle here on the left, you're memorizing 3 things, and that's the dimensions. 1, √3 opposite the 60 degree, and 2 is the hypotenuse. Same thing with this 45-45 triangle. You're going to memorize 3 things, the dimensions. From those 2 triangles, you can always figure out any trig function in the first quadrant. The only ones they expect you to memorize, which are the multiples of 30, 45, and 60. They don't
ask me about 90.
Memorize 31 or 32 degrees. Yeah, we'll get to the quadrangles in a second.
Okay.
There's a couple ways to memorize the quadrangles. There's another concept at play here also, and that is that when I draw, let me erase these 30, 60, or 45 marks there, because I want to do something else here. If I have a 30-degree angle, and it's a unit circle, In other words, that is radius of 1. What are the coordinates of that point right there? Turns out the x coordinate is the cosine of 30 degrees, and the y coordinate is the sine of 30 degrees. Why is that? Well, what's the cosine of 30 degrees? It's the adjacent side over the hypotenuse, which is 1. That's why they call it the unit circle, is because no matter what angle I'm talking about, the hypotenuse or the length of that ray is 1. And because it's 1, it makes the x coordinate the cosine. And in other words, if I say that's the x coordinate right there, well, the length of that adjacent side is x. So I would say the cosine of 30 degrees equals x over 1, right?
Yeah.
Adjacent over hypotenuse, which makes the cosine of 30 degrees equal x. Okay? That's true completely around the unit circle. In other words, not only do they want you to know what the cosine of 30 is and the cosine of 45 and the cosine of 60, as well as the sine, but they want you to know that those are the x and y coordinates around the unit circle, no matter what the angle is. In other words, earlier I was talking about the 150 degree angle.
Yes.
That's this angle here, 150 degrees. So what would the coordinates be on that point right there?
Sine of 150, or cosine of 150 and sine of 1.
Right. So what's the cosine of 150?
So that would be 180 minus 150. Okay. So that would be 30.
Okay. Now go down and look at the triangle. What's the cosine of 30?
Square root of 3 over 2. And that'll be negative.
Okay, so it's negative root 3 over 2. And what's the y coordinate?
The y coordinate will be sine of 30.
Okay, we already figured that out. That was 1/2.
Correct.
So when they say they want you to memorize the unit circle, they kind of want you to memorize the coordinates on every slice, all 16 slices. In other words, they want you to be able to label for 30, 45, 60, 90, 120, 135, 150, 180, all the way around the circle. And the way you get these are by these two things over there. Just remember that the cosine of the angle is the x coordinate, the sine of the angle is the y coordinate. With me?
Okay.
All right.
Yes.
Now we have a way of doing the quadrangles. Let me show you. There's a couple of ways, and the way I'm going to show you, not the way I typically tell people to memorize the quadrangles. Personally, I think that at some point you need to memorize the sine curve and the cosine curve. And once you memorize those two curves, you'll know what the quadrangles are. So let me just introduce these to you since I started talking about it. There's no getting around it. You have to memorize these two curves. So let me draw them. I'm going to draw the sine curve over here, and I'm going to draw the cosine curve here. And these might be the only two you might have to memorize. You might have to memorize all of them. You do, but Trig is all about memorizing stuff, more so than any math you've had to this point. Sine curve starts out at 0. and goes to 360. And you need to memorize these. They're called quarter points also. Now, that's all you need to memorize. That's y equals sine x. This is the x-axis. This is the y-axis.
Okay.
So what's the sine of 90 degrees?
That would be opposite over hypotenuse.
Look at the curve. In other words, there is no 90 degrees up here. You can't,
Oh, so that'd be 0.
that right angle, incidentally. You can only use these two triangles for 30, 60, and 45.
Okay.
Okay? 90 is a quadrangle. You're going to get it from this curve. So go to 90. What's the value?
At 90.
Uh-huh. What's y?
Would it be 1?
Uh-huh. What's the sine of 0?
That would be, yeah, it would be 0 and 1.
No, just 0. In other words, the sine of 0 is this point right here.
Yes.
What's the sine of 180?
So that would be, would it be 180 minus?
Right? What's the y value right there?
Oh, that would be 0.
What's the sine of 270?
That would be negative 1.
And what's the sine of 360?
0.
Okay, there's your quadrangles. And this is
Okay.
the curve you're going to need to memorize anyway. Now let's look at cosine. And the key thing about these two curves is that their key points, 0, 1, minus 1, all come at these quadrangles.
Okay.
Okay, that's 90, that's 180. And you can list these in either radians or degrees. If you're doing stuff in radians in your class and you want to start doing it in radians with me, I'm happy to do it that way. What is the cosine of 0?
1.
Correct. What is cosine of 90 degrees?
0.
Cosine of 180?
Negative 1.
Okay. If you memorize these two curves, you'll know all your quadrangles, except for one. What's the sine of 450 degrees?
Would I have to subtract the...
All multiples of 360 that you can out of whatever angle they give you.
So 450 minus 360?
Which is?
90.
And so the sine of 450 is the same as the sine of 90. It's 1.
Or 1, yeah, 1. Okay.
So you can now do any quadrangle. Okay, now I'm going to continue this in the other direction because of course that's what it does. It repeats. What is the sine of minus 90 degrees?
Would I add 360 or would I add 180?
Read it from the chart.
So minus 90, that would be negative 1.
Correct. There's a negative sign that I covered up right there. Okay.
All right.
What's the cosine of minus 90?
That would be 0.
Correct. Notice that the cosine curve is perfectly symmetrical with the y-axis. That means it's an even function. That means the cosine of minus x equals the cosine of x. That's why it's positive in the fourth quadrant. is because it's an even function.
Okay.
The sine is an odd function. By that, I mean it's symmetrical not with either axis, but with the origin. Odd functions are always symmetrical with the origin, which means the sine of minus x is equal to minus the sine of x. I don't usually give these in my first trig tutoring session, but I think it's worth getting that information now because it's going to come in handy whenever you're dealing with negative angles. In other words, if they ever give you a negative angle, you can use these properties to convert it to a positive angle. If I said, what's the sine of minus 90? Well, you could say, well, that's got to be equal to minus the sine of 90. And if I said, what's the cosine of minus 90? That's got to equal cosine of 90. Okay? Now, there's another way to memorize the quadrangles that a student told me his teacher used, and it makes kind of a lot of sense. Let's go back up here. The coordinates on that point are cosine of x, comma, sine of x, right?
Okay.
If my angle is 0 degrees, then my ray is right there. What are the coordinates on that point? Is it not 1, comma, 0?
I'd say, yeah, I'd say 1 and 0.
Yeah, actually I didn't draw the point right. The point is right there, okay?
Okay.
The coordinates on the point where the unit circle intersects the x-axis have to be 1, comma, 0. We're on the x-axis, so the y-coordinate is definitely 0. The x-coordinate is 1, because that's the radius of the circle. And we know the x-coordinate is cosine x, and we know the y-coordinate is sine x. So if you think of it like that, now let's go to the 90-degree angle. Okay, I'm going to draw a 90-degree angle right there. The coordinates of that we know to be 0, comma 1, correct?
Okay.
So
yes.
now you know that the cosine of 90 degrees has to be 0, and that the sine of 90 degrees has to be 1.
1.
And you can go around the whole unit circle like that. In other words, when I get over to here, this point here, well, clearly that's negative 1, comma 0. So the cosine of 180 is negative 1. The sine of 180 is 0. Get down to here, finally, the 270 angle, and I can see that the coordinates are 0, comma, negative 1. So if I remember those 4 coordinates, and I don't even have to memorize them, I can just look at the unit circle and figure out, well, that's 1, comma, 0, that's minus 1, comma, 0. That, in effect, gives you a way of memorizing your quadrangles. As long as you understand that every point on the unit circle, the x-coordinate is cosine x and the y-coordinate is sine x.
Okay.
Now, have I covered everything? Not quite. Yes, I have, kind of. I've even covered negative angles. And
I don't know if you'll ask me negative per se.
You
but
can
maybe.
always treat negative angles the way I've told you down here. Convert them to positive angles.
Okay.
Now, have you gone further than this in your trig class? Or just further than you've gone?
This is where we pretty much like stop. Our teacher said that he wants us to memorize the 100 something things in the unit circle.
Yeah, it's silly that they want you to do that. It really is. I mean, that's a terrible thing to ask anybody to memorize. It's like if I gave you a 16-digit credit or credit card number you wouldn't memorize it as a 16-digit number. You'd memorize it as 4 groups of 4, right?
Correct. I'd forget it most likely easier.
Well, it would be easiest to memorize it in groups, not all.
As one big heap.
They take this unit circle, that's 30, that's 45, that's 60, that's 90. So there's 4 slashes per quadrant times 4. There's 16 points, and there's 6 trig functions. So they're telling you to memorize 96 things. Well, I just showed you how to get any of the 96 by using this page only. Now, there is one other thing you need to know. Do they want you to memorize all 6 trig functions? Or just 2 or just 3?
They want me to memorize all the trig functions.
Okay, so let's talk about cotangent, secant, and cosecant. Because if you can just memorize which are the reciprocals, in other words, if you can memorize the 6 reciprocal relationships, and let me give you a way to do that. These are what some people would call the 3 primary, but in actuality they're no more primary than the other 3. It's just that on some of the older calculators, these would be the only 3 keys you'd have, and if you wanted one of the other 3, you'd just take the reciprocal of it. Well,
Okay.
if I said, what's the reciprocal of tangent? What would your first guess be?
Cosine over sine.
Cotangent. Cotangent goes with tangent, like peanut butter and jelly. And I'll explain that comment in a moment. What's the reciprocal of sine? Is it secant or cosecant?
Cosecant.
And the reciprocal of cosine?
Secant.
That's all you have to remember. And one way to memorize it is that's S, that's a C, that's a S, that's a C. In other words, the S never goes with the S, and the C never goes with the C. They always go with, it's an SC combination. So if you forget these, that's one way to memorize it, as to which goes with which. Okay? Now, this is what you have to memorize, is these, when I said now, I meant to write the rest of this, which makes cosecant equal to 1 over sine, secant equal to 1 over cosine, and cotangent equal to 1 over tangent. So there are 6 reciprocal relationships. Okay? So earlier you learned that the sine of 30 degrees equals 1/2, right?
Mm-hmm.
What is the cosecant of, I hate Windows. Hold on. I hate it when I get anywhere near down here, those windows pop up and they obstruct my writing area. So what's the cosecant of 30 degrees?
2 over 1, or 2.
That's exactly the way you do the other 3 trig functions. In other words,
Okay.
as long as you can memorize the sine, cosine, and tangent of those basic 3 angles, then you can always figure out the cosecant, secant, and cotangent just by taking the reciprocal of the number you came up with when you did the other functions. Now, so that leaves you in a point where I should be able to ask you all 96 slices and you should be able to tell me the answer right now. If you had this page available to you, right?
Correct.
Let me test you a little bit.
All right.
what is, I'll write it up here, the tan of 210 equal to?
Okay, so that means I'll be in quadrant 3. So 210 minus 180 is 30. So then opposite and over adjacent, so that would be 1 over square root of 3.
Rationalize it.
That'll be square root of 3 over 3.
And then is it a plus or a minus?
It'll be a plus because it's in the third quadrant. Third quadrant.
Okay, now notice what happens when I say what's the cotangent of 210?
It'll be 3 square root of 3 over 3.
Which
And
is,
then it'll just be square root of 3 over 1. And it'll be square root of 3.
in other words, sometimes you're better off leaving it unrationalized because you frequently need to take the reciprocal of it. So if I want to say that that's 1 over root 3, that makes finding the cotangent a little easier, right? Whereas
Yes.
if I rationalize it, then you have to rationalize the cotangent. So it's not bad to memorize that as 1 over root 3, as long as you realize that you never are going to give that as an answer on any test or in class. You're always going to rationalize it before you give it as an answer, but that's just as valid of a number as root 3 over 3 is. It's the same exact number. And it almost makes trig a little easier if you leave it unrationalized.
Okay.
Only to when you're dealing with the other 3 trig functions. So is there any trig function of any angle that's a multiple of 30, 45, 60, or a quadrangle, or for that matter, any angle that's coterminal to that? You know what the word coterminal means?
The reciprocal?
It's multiples of 360.
Okay.
In other words, if I said, what are all the angles that are coterminal to 0, it would be 0, 360, 720, 1080, so forth. So when I gave you that angle 450 degrees, that was coterminal with 90. And if you are given an angle that's greater than 360, you always want to reduce it back to inside the unit circle. In other words, you want to get it down to an angle that's less than 360. So if I gave you 750, you'd take 2 multiples of 360 out. You'd take a 720 out, and you'd end up with 30 degrees.
Okay.
Okay? I'm giving you a ton of information here to absorb. And at some point, I want to stop just feeding more information because I know that, there's danger of just after a certain amount, it just goes in and comes out. So, but you seem to understand. I believe you could do the unit circle now, every step of it.
Yeah, as long as I can write this down. Like, I want to memorize this and write this down ahead of time, like when I get to the test.
Well, I tell you one thing you can do right now. Take a picture with your camera of this page. Here,
Okay.
let me get rid of the unnecessary stuff. Now, you know how to access these files. This is being recorded, and you can always access it also. Hold on. Let me get rid of that. One thing I did not want to get rid of. My circle that wasn't that great a circle.
Oh, it's fine. It served its purpose.
Mainly, I want these these quadrangle points to be right. There you go. I think, yeah, take a picture of this page. And this actually does allow you to fill out the unit circle for all 6 trig functions.
Okay.
Not quite this page, but this page in combination with the reciprocals, but you got those memorized. So, and you don't even need these two graphs. So you're going to have to memorize these two graphs at some point. So I would start working on it, because to me, the easiest way to do the quadrangles is with these two graphs. It's not this other way. In other words,
Okay.
looking at these points for 0, 90, 180, and 270 is a way to do it, but I prefer, I know these graphs by heart. I could draw these in my sleep. So I use the graphs. But you also need to know these reciprocal relationships in order to do the other three trig functions. But everything on this page you see right there is enough to memorize sine, cosine, and tangent for every slice of that unit circle.
Okay.
Now, when they say that you have to memorize the unit circle, you have to be able to fill out the x and y coordinate at each point, right?
Yes.
So you definitely need to know that the x-coordinate is equal to the cosine of x, and the y-coordinate is equal to the sine of x. I'm going to leave this on here. In other words, it might not be sufficient to just know what all the sines and cosines of all these angles are. You also have to know that the x and y coordinates, they're the cosine and the sine.
Okay.
Okay, so what's the x and y coordinate of this point right there? In other words, for a unit circle?
So that would be of 30 degrees.
Right.
So I believe that would be 1 and 0.
No, it's, look at your triangle down here. In other words, this is an acute angle. This is not one of the quadrangles. The quadrangles are 0 and 90. But this coordinate point right here, the one I was pointing at, that one, maybe you thought I was pointing at this one down here. This one that's at the end of the 30-degree ray?
Yes.
So what are the x and y coordinates? I've labeled them as cosine x and sine of x. So you got to figure out what the cosine of 30 is.
Okay, so that would be square root of 3 over 2.
Okay, so that's what my x-coordinate would be. What's the sine of 30? 1/2.
And the sine would be 1 over 2.
That's a good one to memorize, incidentally. The sine of 30. That comes up so often. Either the sine of 30 or the sine of 150, which is the same as the sine of 30, and 1/2 is a nice easy number to memorize. So I would kind of get used to remembering the sine of 30 degrees is 1/2. In other words, they're going to want you to go through all 16 slices and give these two numbers at each point. You just gave it to me for 30.
Okay. So,
What is
you're asking for other
45?
point? So for 45,
Yeah, if I draw a line to 45, what's the coordinates right there? Yep.
okay, so the cosine will be 1 over square root of 2.
Okay. And then you're going to want to give
That'd be square root of 2 over 2.
Yeah, you're going to want to give it like that. And what's the sine of 45?
So opposite over hypotenuse, so that'll be the same thing, square root of 2 over 2.
Okay. That's how they're going to want you to present the unit circle. It's not just knowing the angles, it's labeling the x and y coordinates at each slice.
Okay.
Okay? Yeah, they let you take a cheat sheet in, and I'd say about half my students will have teachers that will let them take a cheat sheet for trig, just because there's so much to memorize. This would be a good one to take in.
I wish. My teacher doesn't let us bring anything except what's in our brain.
you'll notice that there's a pattern to some of this stuff. First of all, the two triangles on the left, you've been working with those a long time, so you should kind of have those semi-memorized.
Okay.
SOHCAHTOA, you got that memorized, I know you do. Notice that this second quadrant's 180 minus theta. This is the reverse, theta minus 180. And if you forget which way it goes, which is easy to do, look at the fourth quadrant. It's 360 minus theta. And that's similar to the second quadrant. So the second and the fourth begin with numbers. The third begins with the theta.
Okay.
Let me think if there's anything else. The all students take calculus helps you remember. In other words, a lot of this stuff you can memorize just by the pattern of it. Erase that. Did you take your picture yet of this page?
Yes.
Okay. Yeah, that should do it. I think if you had access to this in your memory, you'd be able to put every single slice, at least for sine, cosine, and tangent. All right. Now, we still got 20 minutes. What should we do with the next 20 minutes?
I have no idea. Like, that was the main concern that I really had, was memorizing this, because I wanted to learn the best way.
Well, I certainly have an idea of what's coming up next. I can get you a little ahead of the curve if you want.
Sure.
Let me just look in my book here. Yeah, let's talk about some identities. It may not be coming up next, but it's coming up, and it's all about memorization. Memorize those two curves also.
Okay.
That's going to be part of what you have to memorize. You might want to take a picture of that real quick.
Okay, I'll do that right now.
That I have up there right now.
Got it.
Notice what the period of the sine is. It's 360 degrees, or if it's in radians, it's 2 pi. Same with the cosine. And the period is always from peak to peak, or valley to valley, or this midpoint heading up until I get to this midpoint heading up. Period for the basic sine and cosine function is 360 or 2 pi. You're going to rapidly convert to radians, or are you already there? Doing stuff in degrees at this point, or radians?
I believe right now we're in degrees.
Okay. You know the conversion factor, right?
Yes, when we're going to radians, we divide it by 180, and if we're into degrees, we multiply it by 180.
Well, not quite. Here's the relationship. The thing is 180 over pi.
Okay.
That's the conversion factor, or pi over 180.
So pi over 180 for... Okay.
So if you're converting 90 degrees, which one do you use?
Pi over 180.
What does that become?
Radians?
Yeah.
That would become
90 degrees.
That would be 1 over 2.
Pi over 2.
Or pi over 2.
Leave the
Yeah,
pi out. Pi is critical. For one thing, almost all angles that are in radians are going to have a pi in it. Okay? And this is actually a number. We don't typically add the units to that. We don't generally say pi over 2 radians. That's a number. That number is 3.14 over 2. Okay? And that's a critical point about radians. I don't want to really go into the explanation of it, but radians and degrees are not really like gallons and liters. In other words, even though we have a conversion factor here, mathematically, the two are as different as night and day. When you get to calculus, everything has to be in radians. You can't deal in degrees. when I say the derivative of the sine is the cosine function, that's only true if the argument is in radians, not degrees.
All right.
So you know how to convert between degrees and radians. Let's talk about some of the more basic identities. We've already discussed the 6 reciprocal identities. There's also, let's kind of memorize them like this. 6 reciprocal. You know how to write all 6 of those, don't you?
I believe so.
Okay, and then there's
Yeah, I believe so.
And then there's 2 quotients. And the quotient one, I heard,
Sine over cosine and cosine over sine.
yeah, tangent equals, and the only one you need to memorize is that one, right? There's actually 2 of them, but the other one you could figure out because you know cotangent is 1 over tangent, so you'd flip that. So cotangent has to be cosine over sine.
Okay.
And then there's 3 trig identities. The first one they're going to teach you is sine squared plus cosine squared equals what?
I believe that's 1.
Correct. The second trig identity, you're going to have to memorize it. There's no other way. Tangent of x plus 1 equals secant squared.
Secant. Okay.
Okay? Memorize those 2. And then the third one is the cofunctions of the second one. And before I confuse you with the word cofunction, we haven't talked about cofunction yet. Let's do that now. Cofunction merely means the trig function with the word co in front of it. So the cofunction of sine is cosine. The cofunction of secant is cosecant. And the cofunction of tangent is cotangent. These are the easiest ones to remember.
True.
Okay? And don't get mixed up between reciprocals. These are not reciprocals. Even though the tangent and the cotangent go together in both as cofunctions and as reciprocals. That's why I said they're like peanut butter and jelly, because they go with each other no matter whether you're talking reciprocals or cofunctions. Whereas secant doesn't go with cosecant as a reciprocal, but it is the cofunction. And likewise, the cofunction of cosine is sine. Okay? So it's a two-way relationship. Now, as long as we're talking cofunctions, they all share a very interesting property, which is this one. Sine of x is always equal to the cosine of 90 degrees minus x. Same thing with secant, cosecant, and same thing with tangent, cotangent.
Okay.
Remember when we were talking the sine of 30 degrees, it was 1/2? Cosine of 60 degrees is 1/2. We go back and look at those triangles, you'd see that the sine of the acute angle is always the cosine of 90 degrees minus that acute angle.
True.
Okay, so cofunctions have this property, which is a key property. You won't maybe get to cofunctions for a while, it's possible. The only reason I brought it up now is because it helps you memorize these identities. In other words, you know the 6 reciprocal identities. You know, and of those, you only had to memorize 2 of them. So in other words, if you can memorize sine and cosine, that's all you have to memorize, right? You know tangent goes with cotangent no matter what you're talking about. So you have 2 things to memorize for the 6 reciprocals. you only have to memorize one thing for the two quotients, and you only have to memorize two things for the three trig identities. So you memorize 5 things and you can work out all 11 of them. And these are your key 11 trig identities. They're going to teach them to you, and then they're going to make you verify trig identities for about 2 weeks so that you'll learn them. It's the best way to learn them is to go through trig identities. And the only purpose of verifying trig identities is to learn these 11 identities. Okay? But it's kind of like the 96 slice unit circle. You don't have to remember 96 things. You just have to remember a bunch of things in groups of 3 or 4, which is that first.
So it's not jumbled up.
Yeah, and then that's a good thing to memorize there. Actually, boy, if I took this whole thing, you could almost pass a trig final if you memorize that page, that page, that page, and that page, not the circle. I'll erase the circle. And I'm serious. You almost could. You could almost get through a trig final with just the stuff on these pages. But it's still it's a significant amount of stuff to memorize.
Okay.
I'm not sure how you memorize stuff. I know what I believe is the best technique. I'm not sure that it's so applicable to trig, but it certainly is applicable to all of mathematics, and that is flashcards. There's a school in Denver, probably one of the best high schools in Denver, and they almost force feed their students. They require them to not only make flashcards, but turn them in to prove that they made them.
That's crazy.
The teacher checks them and then hands them back, and then the student can use them. But it sounds crazy, but it's not as crazy. It's crazy like a fox, because as the student makes the flashcard, he starts to memorize it. That's a critical part in memorizing it, is the act of making it. In fact, you probably will have half of them memorized just by doing it. Now, that's not quite, it might be kind of hard to make flashcards for trig. You wouldn't want this page to be a flashcard, but you might want a flashcard that had this triangle here on it, and on the other side of the card it said 30-60 right triangle. Okay? Because what you need to memorize are the dimensions. It's not the triangle you're memorizing, it's the side opposite. Oh, and incidentally, I call these two triangles my unit triangles, just like the unit circle. And the reason I do is because the side opposite the smallest angle is always 1. That's 1. Once you work out that that's 1, and this is √3, you can always calculate that, figure out that it's 2. Same thing over here. The side opposite the smallest angle, 45, is 1. Both that one and that one. Once you memorize that, you can work that out, that it's square root of 2.
Okay.
So you could use the concept of flashcards, although I still think it might be a little difficult with trig. Don't have any other real good clues as to teach you how to memorize this page, but that's what you need to do. The curves, yeah, there's 2 really good things to memorize with sine and cosine. Sine starts out at 0 and rises. Cosine starts out at 1 and drops. Notice that cosine starts at 1 and immediately drops not just to 0, but all the way to -1. Whereas sine starts out in the middle, goes up to 1 as its first move, and then back down to 0, and then down to -1. And so that maybe helps memorize sine and cosine.
Okay.
How would I graph y equals minus sine x?
Oh, y equals minus sine
Yeah.
equals x.
Looking at the sine curve here, how would you graph it if I said graph y equals minus sine x? What's the effect of the minus sign? Think in terms of transformations that we've talked about.
Flipping it over the x-axis.
So minus sign would look just like this. Notice same with cosine. If I said, what is y of minus cosine x? Well, that looks like this. It's flipped over the x-axis. Now, notice that I didn't say what is cosine of minus x, because the cosine of minus x is equal to the cosine of x. But if you have the minus sign, in other words, up there, the cosine of minus x, because it's an even function, is equal to the cosine of x. But if I actually had the minus sign in front of the trig function, then it would be a reflection over the x-axis.
Mm-hmm.
You think, let me erase that, illustrated my point. Well, that should take you a long way into your first few weeks of trig. Everything on these pages here. Let's see if I can think of anything clever to say in 3 minutes that is pertinent to trig. Let me just look in the book real quick here.
Okay.
Yeah, there is something really quick. And that's inverse trig functions, which you might get to sooner than that might actually come up next. If the sine of 30 degrees is equal to 1/2, then by definition, the inverse sine of 1/2 equals 30 degrees. And notice what's happening. This is if and only if, but those two things are equal statements. We take trig functions of angles to get ratios, correct?
Yes.
We take inverse trig functions of the ratios to solve for the angles. In other words, I'm going to give you another triangle that you've dealt with for 3 years, the 3, 4, 5 right triangle. Well, nobody's taught you what that angle is, I'll bet. Nobody talks about that angle. Approximately 37 degrees. Okay?
Mm-hmm.
But if I wanted to know what that angle was, I could take the inverse trig function of 3/5, and that will tell me what theta is. Now, I have to put that into my calculator, but your calculator has an inverse trig function button on it. So you'd put it in as inverse sine of 3/5, and it would tell you that that angle is 37 degrees. And if you did the inverse sine of 4/5, it would tell you that angle was 53 3 degrees approximately. In other words, you use the inverse trig functions to solve for angles. If I drew a real complicated figure on the screen made up of all kinds of triangles, and I said, what's this one angle here? Well, if you know the dimensions of the triangle, you can solve for the angles. You know, if I'm looking at a mountain range, and I want to know how tall the mountain is, and I measure, well, let's say I know the mountain is 20 high, and it's 100 away from it, I can figure out that angle. That's the inverse tangent of 20 divided by 100.
Okay.
Over here, theta is equal to the inverse tangent of the dimensions, the opposite over the adjacent. That's another thing. You don't want to just memorize SOHCAHTOA. You want to know it. You don't memorize your name. You know your name. If somebody says, what's your name? You don't have to access your memory to come up with it, right?
No.
Well, every time I've asked you about a trig function, I can tell that you're trying to memorize it based on SOHCAHTOA. In other words, when I say what's sine, you go, oh, it's opposite over hypotenuse. You want to get beyond that. You want to know instantly that it's opposite over hypotenuse. In other words,
Okay.
memorize SOHCAHTOA so that you know it like your name, Taylor Penn. Okay? And that's just something about trig. You don't want to constantly having to be making these translations in your head. You want to know instantly when they're talking about sine of a right triangle that it's opposite over hypotenuse. All right,
Okay.
Taylor, I'm going to let you go.
Thank you. Have a good night.
Yeah, you too. Talk to you later.
Bye.
Bye-bye.